8 a.m. But thanks to everybody for showing up. I've got a couple of announcements just to get us started here. First, there we go. The CTF had a couple of hiccups yesterday, but it's fully up and running. So everybody who wanted to participate in the Capture the Flag, that's still going on in Penrose 2, just right upstairs. Everything's ready to go. We've got, so if you want to hop into that, it's not too late. The award ceremony from last night's Code Brew competition is being pushed back to the award ceremony with everything else, with all the raffles and whatnot. There were also a couple of hiccups with the Birds of a Feather session up in Penrose 1, where we didn't have the sign-up sheet. We have that resolved, so if you guys are interested in participating in Birds of a Feather this morning, we'll have that sign-up sheet all ready to go. So right after the keynote, we have a little bit of a break, and you can head up there and put up a talk. I think I saw that some people had already started doing that, so there should be some talks already filled in. So definitely take a look and see if there's anything you're interested in discussing. Today's agenda, we're going to kick off with Gary McGraw. Right after, he'll be doing a book signing at the Digital booth in the Sponsor Expo. We do have that CTF running all day. Later on, we're going to have the global board of OWASP having a panel discussion. Then we've got all the wind-up stuff, so all the raffles and contests. So today's the last day for you guys to get your sponsor passports filled out and submitted. And we've got a bunch of cool prizes for that. We've got tablets and books and games and all sorts of fun stuff we're giving away. And then after everything else, we'll be having a brewery tour of downtown Denver. We don't have anything at 8 o'clock tomorrow morning, so certainly participate in this. We're going to be meeting in the hotel lobby, so just right upstairs, a couple of floors at 7 o'clock. And the whole time that's going, we'll write down a Twitter hashtag on the board where we're asking you to assemble. So if you get there a little bit late, we're going to be tweeting out every time we arrive and depart from any location. So feel free to meet us up if you're out for dinner or whatever else. Just see what the hashtag is going to be. I don't know it offhand. And follow along, catch up, join us for some beer. I want to thank our sponsors again. They've just been completely integral to putting this off. This whole show is 100% because of them. Please, if you have not visited their booths, stop by and say thank you. Our keynote today, he wrote the book on software security, and then he wrote another, and then he wrote another. Whoa.
Do the thing I told you.
Yeah.
There you go.
That's.
It's annoying, isn't it?
It's definitely interesting. Gary McGraw is a widely acknowledged authority. He's been writing about secure code and exploiting insecure code for a couple of decades now. He has a body of work. He's a visionary in the industry. His books, his insights, his contribution to the security community have been shaping the software industry for about 20 years now. It's my great honor to introduce Dr. Gary McGraw.
Thank you. Got to switch it over to my slides here. Good morning, everybody. You're crazy. I would not be here if I didn't have to be here. So thanks for coming. I thought I would start with two things. First, I'm going to do a quick roll call. So Flea, here. Lisa, JP, Jeremy. Here. All right, we were out drinking last night, so just making sure that they showed up for school this morning. Thanks for coming, you guys. And then a quick confession. I'm a software guy, not really a security guy. I got into security because software sucks. And I thought, you know what? Now that security's all on the interwebs, when Java came out, maybe what we should do is figure out a way to use security to make software better. So I want to talk to you about what I've been doing for the last 10 years on that front. I actually started coding when I was 15 or 16. I got an Apple II Plus with 48K in 1981. And then I went to philosophy school where no coding happens. And then I went and got a PhD in computer science with Doug Hofstadter at Indiana University in cognitive science, which has nothing to do with security. And I joined Cigital when it was called Reliable Software Technologies in 1995. We're now called Cigital. There were 7 people. I was employee 18 because we counted dogs and goldfish and stuff with early employee numbers, right? And now we've got 350 people, so it's been incredibly great to watch that thing grow. I got started in security because of the work that I was doing with DARPA on taking some ideas from software safety and applying them to security. But when I was doing that for DARPA, Java came out. Anybody heard of Java in here? Yeah, and Java had all sorts of crazy things. There was, those crazy evangelist people running around going, Java is secure, and everything you write in Java is secure, and secure. And Ed Felton and I just thought about it, and we were like, what the hell does that mean? It's a programming language. How can everything that you write in a programming language be secure? And what is the security model? And I wonder if it breaks. And you know what the answer was way back then? Oh yeah, it breaks. So I got my start in the early days in 1996 breaking Java an awful lot. And when Java started breaking again, what was that, 6-8 months ago, something like that? It was like a time machine to 1996. Some tech press people called me up and they said, didn't you do Java work, 12, 15, 17 years ago? And I said, yeah, or whatever it was. I said, yeah. And they said, well, what do you think of the new stuff? And I said, it looks just like the mistakes we were making in 1996. So we've learned some stuff and we've made some progress, but you guys, we have not made enough progress. And we need to work together to get software security, and I guess we could call it application security, but I call it software security, spread more widely on the planet. Everyone in here is integral to that. We all have to do it together. I got started thinking about software security, in particular with John Viega. We wrote the book Building Secure Software in 2000. And the reason that we wrote it is because we were thinking, why did Guy Steele, who's probably the best programming languages person ever to live on the planet, who's still alive, by the way, and Bill Joy, who's no hack, he sort of, wrote Berkeley Unix all by himself. Why did they screw it up when it came to security in Java? And if you were not a super ultra wizard, but you were just sort of a normal, good, solid geek, where would you go to learn not to screw it up? And the answer was nowhere. There was, 2600 and some issues of frac, but that was all about breaking stuff. And there was some stuff that Bishop and Dilger wrote in the literature about, race conditions, the TOC2 work. And there was maybe Aleph 1 stuff, smashing the stack for fun and profit. But there were 0 books on software security. So we wrote one. And that was, I guess, 14 years ago. And I want to talk to you about what's happened since those days. So the real problem was way back in the beginning, computers were expensive and people were cheap. So not many people had computers and you had to sort of walk into the room where the computer was. Remember that first bug was an actual bug that Grace Hopper found in one of those slider thingies. The switches used to be physical and a bug got stuck in one. And that's what the first computer bug was. In those days, the computers were so expensive that if you wanted to use a computer, you had to genuflect to the administrators who ran the computer. And you often had to write your program on a table with a bunch of paper and pencils and stuff and do some proofs. And then you would punch it in with a Hollow Earth punch card thingy. And then you would take it to the computer people and you would genuflect at the window and slide your cards in. And if they were not folded, spindled, or mutilated in any way, maybe they would run them. And you know what? If you had a bug, they just threw your cards back at you. Come back when you're grown up. Because computers were expensive and people were cheap. Well, my oh my, things have changed, haven't they? Now we all have computers in our pocket. And computers are cheap and people are expensive. And computer security is not quite caught up to that big flip-flop between what costs more yet. Plus, all the stuff that we built way back when for geeks to use is now being used by normals. There are no normals in here. You're all geeks. Sorry. Right? And the normals, they really don't give a damn how this stuff works. They don't care if it's web, schmeb, mobily, schmobily, whatever, cloud. They don't care about any of that. They just want to get their banking done. They just want to buy some stuff. They just want to, look at their Facebook stuff and like a bunch of things. And so they don't really care. We can't ask them to be part of the security solution. We just have to make it invisible and automatic and better. And the way to do that is to build things properly in the first place. The first shift happened when we took the computer, which ran one program at a time, and we started doing multitasking. And then we ran a wire outside the room to something called a terminal room, and everybody got VT100s and ADM5s, which you can still bell, by the way, in most browsers. Right? So, and they were in the other room. And so all of a sudden we had a security issue because instead of the wizards in the room running the only program, there were 20 people out there that were running. So of course they were geographically located, so if they screwed around with your machine, you could run over there and beat them. And the power was still in the hands of the system administrators. And in fact, I believe that one of the problems in our own field of application security is there are too many system administrators and network security people and not enough software people. We have got to be software people. If you can't code and you're working on this field, for God's sakes, go learn to code. Really. And if you want to get developers to listen to you, be one. And if you want to do architecture analysis, you better be a security architect, right? Because if you go and talk to the architecture wizards and you talk to them about silly little bugs, your conversation will last about 10 seconds and they will never talk to you again. So I hate to be hardcore about it, but this is a software conference. Software security, or application security. Now, why do I not like the term application security? Well, I will tell you. I don't like it because it's the network version, network view of our field. It came from security. We just walked up the OSI stack. We got to level 2, we got to level 3, and finally we were at level 7, and somebody said, what's that called? Oh, level 7's the application layer. Cool, well that's the new security. It's application security. Dude. Right? Guys, that's network thinking. The name of our field alone makes it clear that you're not really a software person. That's a problem. So we need the software people to do the right stuff. The good news is if we show them the right stuff, they often want to do the right stuff themselves already. Right, so there it goes. I don't know, I got this new operating system and we're having wonderful fun. Now, who should do software security? I'm getting nothing. There we go. Well, if you take the network view, you go over to the network guys back in the early days, like 2000 or so, when we were starting to think about software security, and we thought it was important, we go to the network people and we go, software security, what do you think? And the network people would go, yeah, we have a great network. It's all like set up. The only problem we have is users. The users really suck. Don't like them. Worst users of all, those users with compilers, they really totally suck. They're over there, and if it weren't for them, everything would be great. So if you want to do software security, why don't you go make them make code that doesn't suck? And we're like, okay, great. Sorry, you feel that way, no problem. So we go over to the dev people, and we're like, yeah, software security, you guys got to do more secure stuff. And they're like, security, yeah, I think that they live in the basement. They don't get much sun. They are a pain in my butt, though. I wrote this incredibly great thing, and it worked really great. It was like a mobile who's what's it. It was all on the web. And then I tried to run it in our environment, and they had all these firewall rules and crap. I couldn't get anything done. Plus, they put this antivirus thing on my build server, and it won't even work anymore. And I hate those guys. Could you just kill them? And so, we're over here, and they're going, yeah, those people really suck. And we're over here, and these people are going, those people really suck. And who's in the middle? Hint on slide. Who's in the middle? Nobody's in the middle. Well, you know who's in the middle now? You're in the middle. That's where we live. And all organizations who are doing software security properly, in my studied opinion, have what's called a software security group, or a product security group, or an application security group. And there are people whose job is to make sure that software security gets done. Now let's talk Business 101. If you have nobody in the middle and you're paying those people, those nobodies, nothing, who gets software security done? Nobody. Yep. And who gets blamed when software security goes bad? Nobody, actually. Nobody has any responsibility. If there's not a software security group, there's a lot of finger pointing and blame just sloshes around and then it just goes away as if it never happened. Who gets credit when software security goes right? Huh? Nobody? No, the CEO, dude. What planet are you from? The CEO gets credit for all the good stuff, right? So don't forget that. Jeez, this is capitalism. Right? So, just a little inside OWASP joke. So the nobody in the middle thing has to change. If you're looking at organizations of your own or your own organization, and the answer is we don't have a software security group, then you have a Management 101 issue, which is nobody has the responsibility and authority to get this done. There should be somebody who gets fired when software security goes badly. And that person should have a big budget and a lot of people, and a lot of software security groups are like that. I know some that have 100 people in them, and they have millions of dollars of budget every year. And usually the person who runs global software security reports directly to the CSO, sometimes to the CFO, sometimes to the board, but most often to the CSO directly. And they have conversations about business stuff, not about cross-site scripting. So time to elevate our game if we want to really do this right. Now, one of the issues that we have in our field is what I like to call the bug parade. I'm sorry to say this, but we have a myopic overfocus on bugs. And there are two kinds of defects in the world: bugs in the implementation and flaws in the design. And the reason that we myopically overfocus on bugs is because, though it's difficult, it's way easier to do bugs than flaws. So we just pretend it's all about bugs. And we even pretend further that our stupid little tool, static analysis tool, will solve the problem. Well, guess what, you guys? It won't. And I've been doing software security for so long, I remember the first static analysis tool for security ever on the planet. It was called ITS-4 in 1999, and we released it open source. And we were hoping that we would get some rules from the community. You know how many rules we got? 0. Yeah, you know how many downloads we got? 20,000. Bill Gates got like 10 or 12 copies. Elvis, Mickey Mouse got some copies, because we didn't really care about that. But that tool was called ITS-4 for it's the software stupid security scanner, much to the marketing people's chagrin, right? And that and RATS were the first two tools ever produced to do this stuff. We've come a really long way since then. Now we've got great tools like the Fortify tool, or Coverity, or IBM's AppScan source, or Checkmarks, or FindBugs, which is an open source tool. There are many software security static analysis tools, and you know what? You should use them. But do not believe for a minute, I forgot Veracode and Veracode, do not believe for a minute that those tools will solve this problem, because they will not. And if we say they will and they don't, it's just going to get us in trouble again. We're going to lose ground. Let's talk about the bug parade. There's always a flavor of the day bug. My very first favorite bug is the buffer overflow. What's wrong with that code right up there? Quick. What's wrong with that code? What? Yell it out. Come on. Thank you, Lee. What? So what? We're setting an array of 12 things, and we're setting the 12th thing to 0, right? What? The first number is the first, what? Yeah, so there's a 0th thing? So what's the 12th thing? Oh, is it really the 13th thing? Is it 13th? Why does it say 12? Oh, we do. You got kids, Lee? Anybody got kids in here? Over here? Yeah? How'd you teach them to count? Did they go 0, 1, 2? Yeah. That'd be a good joke, but that's not how you teach your kids to count. I mean, all I have to say is WTF, you guys. Right? You remember when I said computers were expensive and people were cheap? Not anymore. And C is left over from the days when computers were expensive and people were cheap. Now people are the expensive part, and we still have stupidity like that. Now there was a perfectly good technical reason for that in the day, because arrays are done by offset. So we just multiply the offset times the number of the array index, and we add that many things. So we add 0 to the address, and we're at the 0th place. That's where the first thing lives. And then we multiply times 2, and we get to the, 2 times the offset, and we get to the 3rd place, because it's 2. Right? So, right. So there were all sorts of problems caused by this idea of letting the machine be in charge instead of the person be in charge. We collected a bunch of data. This was actually published by David Wagner, who's still a professor at Berkeley, and did some fantastic work in computer security, still continues to do fantastic work in computer security. And he did this work back in the 90s, and he showed that the buffer overflow was accountable for about half the problems at the time. And the issue was everybody was using the Bible. You see the Bible there? Crossed out, right? So unfortunately in the Bible, on page 164, it tells you how not to do it, ever. There's this function called getS, right? And getS gets input until what? Until the attacker decides to stop giving you some. You don't have to be a hacker. You just have to be patient, right? Which most hackers do that anyway. The real hacking tool in the world? Google. You just Google up a script and you run it, right? So we teach people how not to do it when they learn to code in 101 computer science land, and then 5 or 6 years later in super elite, scary computer science land, we go, all that stuff we taught you about how to do that, and C, don't do that. And they go, huh? So I got to unlearn and then I got to relearn? And that's just C. C sucks. In fact, we should all say C is bad together. Are you ready? Here we go. C is bad. Thank you. C++ is worse. C++ is the worst language ever voiced on planet Earth. It is a pile of stinking poo. Oh, thank you. Somebody, the C++ gods are mad at me. Now, if you want some real buffer overflow problematic code, just look right there. I mean, there's an issue where we're asking to declare a buffer on the local stack, locally, so it gets put on the stack, and it's only 1K long, and we're allowing the attacker to put in as much input as they want so they can just overwrite the stack. This is old school buffer overflow stuff. When we started working on the bug parade, that was the most important bug. And there are literally hundreds of things that you can do wrong in C. And C++, don't even bother, right? Just don't use it. Get rid of it if you can. It's just a terrible language, right? So in 1999, we had this big idea. Gosh, maybe we should make a computer do this, because you know what? I've done a bunch of code review, and it's boring. And it takes forever, and you suffer from what we call the get done, go home phenomenon. Anybody ever had that happen? Yeah, get done, go home. So you're like, I'm going to do this right. I'm going to do a code review of this C code, and then you start looking at the if defs and the includes, and then you're, the defines, and everything's good, and then you go, oh, there's main, that's good, and there's a square, there's a bracket, where's the other one? There's this curly bracket, that's good. This is a function, that's defined over here. Well, that looks like C. That page looks like C. Yep, looking good. It's all C. All right, I'm done. If something is boring, and you have to remember a bunch of stuff, and I mean, God forbid you try to understand the code that guy actually wrote, because the person that wrote that code was obviously on crack for any piece of code, right? So You put all those things together and you're just like, oh, this is a hard job, boring, takes a little bit. I'm just going to have a computer do that. That's what we did in '99. And we've been making great progress ever since. There were some people in the beginning that said, static analysis tools aren't any good. They got too many false positives, blah, 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 blah. Anybody who's still saying that now is trapped in a time warp from the previous decade. Just tell them to shut up or shoot them. I'm from Virginia, so. You do that in Colorado too, right? So it's all good. That's bug number 1. Bug number 2 in the bug parade, the race condition. Anybody ever heard of reentrant code in here? Yeah? Any Java programmers in here? Hold them up if you're a Java programmer. Who's heard of reentrant code? Keep your hands up. Those of you who don't know what that means or who haven't had operating system, you are programming a multi-threaded system where stuff can interfere with other stuff. And you don't even know that. That's bad. In the future, we're going to have these problems with timing where things interact in ways that are surprising. And we all have multi-core boxes on our desktops today. Anybody not got a multi-core machine in here? There's usually one guy. No? I guess that guy stayed out last night. Right? So if you want to think about it in simple terms, we're trying to get thing blue done. And thing blue takes 3 steps, but they're actually what's called a critical section in operating systems land. And we need to put something around them, like some semaphores or whatever, to make that critical section one atomic operation. And if we don't do that, then red people can come and put red stuff in between. And if blue stuff is like, check whether you can do something, then do it, right? And the red guy goes, first you check whether you can do something, and you can, and then the red guy changes it so you can't, and then you do the just do it part. You see the problem? That's a race condition. We're going to have so many timing issues in the future. That's the new buffer overflow. That's way more important and way more interesting than all of the stupid web bugs combined. It's coming, so get ready on that one. My next set of favorite bugs, the Java bugs, we did this. This is, remember Duke? Duke's having a little suicide problem. So we wrote this book, Java Security. You can see that the subtitle was Hostile Applets, Holes, and Antidotes. So really the secret behind that book was Java Security, ha ha, right? And then there was another book about Java that had all these eggs on the front in like a little basket. It was like the Java book with eggs from O'Reilly. We were like, dude, we can so break those eggs. So we did. Those are the secrets behind those book covers from a long time ago. By the way, Securing Java is on the net. It's been free on the net ever since we published it. So open source, free. It's, worth reading as like a study in ancient history of the past. Here are all the bugs. There's a chronology up until 2000 of some of these things, right? And these bugs were interesting, but I'm not going to get into them. Just suffice it to say that the people that designed the sandbox for Java had a lot of problems, and we learned a lot about building sandboxes that don't suck, and we learned a lot about fundamental issues which we still haven't solved, like which part of that static analysis is actually dynamic. Remember the part where they told you that the verifier was doing static type checking? Well, it was sort of kind of doing part of the static type checking, and then later it was doing the rest when the class was around and everything was bound, because it was lazy evaluation. That, my friends, is subterfuge, sleight of hand. So static analysis and dynamic binding, ow, Node.js, oh shit. Seriously, oh shit. Have you thought about this? If the code is not there, you can't check it. Okay, everybody clear on that? Right, so they're like, can you check my new JavaScript thingy? And you go, no, because it's not there. Could you conjure it up and make it there? Then maybe I can check it. So they conjure it up and it looks like that, and you go, yeah, it looks okay for now. What happens when you conjure it up the next time? Poof, completely different. Oh shit. Oh shit. We have a problem with dynamic languages, you guys, and we haven't even begun to think through that properly. Get ready, because if you think it's bad in real Java and C land, it's going to be worse in JavaScript land. Like, oh, they're even, getting rid of stuff like type safety, which is a really good idea. So, there's some good people doing it right. The Clojure guys are doing it right. There's some people making some good progress, and there's some people doing it dead wrong. Ruby. So, sorry. Now let's talk about bugs that we all know about. The OWASP top 10. Woohoo! Why is it the top 10? I don't know. Sounded good. You know, that's fine. They're important bugs. We should learn about them. But top 10 of what? According to what data? Who's our number one? Do you really know? Have you ever looked at the data for what your number one bug is in your code pile? Then why do you know what's number one? Who cares about what other people think? Look at your own code and figure out what number one is. I'm going to tell you a real story about SQL injection. We had a competitor in an account who was doing a review for what was then their customer. And they used the OWASP top 10 to do the review. And they said, Mr. Customer, we did a very intense, hardcore application security review, and we took a look. I'm from Tennessee, so I can talk like that. We took a look at this thing, and we didn't find any SQL injection problems at all. So congratulations on that, no SQL injection. And the customer said, yeah, we don't have a database. And the jackasses, the competitors, said, well, SQL injection, we got to look for that. And the customer said, not if there's not a database. Really? So don't be stupid, okay? Don't be stupid. Don't let some list drive you. Let your tech stack drive you. Be smart. If there's not a database, don't look for SQL injection, right? I'm not even going to tell you what it is. Cross-site scripting. Do-do-do-do! Everybody can find cross-site scripting with their static analysis engine most of the time, right? So you can find 1,200 cross-site scripting issues in one piece of code. But you know what? If you're fixing one cross-site scripting issue, one bug at a time in code, you, my friend, are an idiot. And your developers are doing the wrong thing. And all you're doing is clean up on aisle 7. You're kind of like Mandiant for code. Ooh, clean up on aisle 7. Could somebody please bring the mop? Yes, okay. Dude, that's security. Clean up on aisle 7? That's wrong. That's not how to do it. At Google, Christoph Kern figured out how to change the design of the API and the framework that developers were using for a certain Google product. And their number of cross-site scripting issues dropped from in, where in is greater than 30, to 0. And it held at 0 ever since then because they did it right. They changed the design so developers can't do the wrong thing. That's the smart way to do cross-site scripting. The stupid way is to use a static analysis tool and fix every single bug one at a time. Everybody got that? And you know I love static analysis. I actually really think it's important and we should all use it. Now the real problem is, of course, I've just told you about 5 or 6 bugs. And there are many. There are tens of thousands of bugs. Anybody who tells you it's 10 is on crack. And anybody who tells you it's 25 is 2.5 times more on crack, right? So, it's just bugs are bugs. There's a lot of bugs. And in fact, we could pile the bugs up, and we started doing that when we wrote software security. I did some work with Brian Chess and Katrina, whose last name I can't pronounce. What is it, Flea? It's O'Neill now. Oh, good, O'Neill. Thank God. It used to be like Ski. Yeah, she's a Russian. Right, so, and we took all these bugs and we were like, dang, we got to make some piles that people can understand. How many things can people understand? You know the answer to that, right? 7 plus or minus 2. So we kept pushing around stuff with bulldozers until we came up to 7 plus or minus 2. You'll see there's 8. But that's 7 plus or minus 2. Really. Now when you're doing a code review, you should think about specific bugs and you should use a static analysis tool to remind you of specific bugs, but you better go over a list like this. 2. Have we covered all the big old huge categories of bugs? We need to do some sort of bug biology thing. We called these the pernicious kingdoms because we were borrowing the word kingdom from biology. And biology screws it up. They're like, oh, new species. Oh, yeah, we got to move that around. Oh, we found a thing under the sea. Oh, shit, where's bucket does that go in? Right, so they're moving around. It's not like you can't move around. We can move stuff around. But organize your thinking, please. Don't just use a list. And please, top 10's a good marketing gimmick. But that's all it is. It's not a good execution gimmick. We need to find the easy bugs. And we need to scale static analysis. So I like lightweight static analysis that looks for less, faster, so that you can fix it. Now, that last part, so that you can fix it. I'm going to say that again. so that you can fix it. There's a lot of arguing in our field about SAST and DAST and IAST and whatever Gartner's bullshit is, right? It's bullshit, right? And there's arguing over what's better. You know what, guys? Who cares? Nobody's fixing the bugs. You're all so busy arguing over how to find them that nobody's spending any time fixing them. And we're not making any progress. Now, the answer about whether I should use SAST, DAST, IAST, goat sacrifice, metal-faced boys, penetration testing, the answer is whatever makes it easier for you to fix the damn software, okay? So, if you do static analysis super quick on the binary and it says you got a bug, but you can't fix the binary, what the hell is the point? Seriously, what is the point? Now, if you do a penetration test and they go, dang, we got a problem somewhere in that pile of enterprise Java, one of those beans is screwed up. And you go to dev and you're like, one of your beans is screwed up. And they go, thanks, there are 10,000 of those, which one? And you go, yeah, we just found out with IBM AppScan thing. They go, yeah, why don't you F off and never come back? Seriously, we cannot do that. We've got to come and we've got to say, here's the problem, here's how we suggest you fix it. We're not clear on your design and how you did this exactly right here, but really, generally speaking, you do it like this. And they go, oh, wow, a guy with a brain, all right, let's do that. That's how you do it. We've got to fix what we find, and we've got to stop talking about what's the best technology or making shit up with Gartner, right? Here's the real problem. Bugs. How much of the issue would we solve if we really eradicated all the bugs? Anybody know? Or if we divide up bugs and flaws, what's the division? Let's have a guess if you had to do percentages. Somebody yell some out. What? 90-10 which way? Design, 90 design, 10 bugs. That's interesting. Wrong, but interesting. Anybody else? 40-60 what? So 40 bugs, 40 design, 60 bugs? So more bugs. Yep, that's also wrong. Any math people in the audience? Excellent! Math people, right smack down the bell curve. Phew! The middle. It turns out to be right, too. 50-50. 50-50. In practice, 50-50. Now, we're finding more bugs today. You know why? Because we have static analysis engines. It's because we're looking for them. So we're all like standing under the light going, wow, look, I found some stuff. And you're like, dude, there's dark over there. Maybe you should look over there too. Oh, there's monsters over there. I can't go over there, right? My favorite answer of all time to this, I was training at Qualcomm, and there was a guy who said, in a group of about 200 people, 70-70! And everybody sort of scooted away from him. They're like, yeah, we should take away his compiler. Sorry. Yeah, sorry. You know what? That guy's probably right. They're 40% more than we thought. But get this. If we don't start talking about design, we are not going to solve this problem. And we're pretending we can solve it with stupid little tools. We get to do that once, and then we're done, and someone else will take our place who's better. So start talking about the other half of the problem. We just built this thing called the Center for Secure Design. Dell gave a talk about it yesterday. If you're interested in the Center for Secure Design, talk to Dell. We released a report of the top 10 software security design issues. And here's how we came up with it. We got 13 people together from Google and Twitter and Intel, McAfee, and let's see, EMC, RSA, Foundation, Sardosky, that was actually Yvonne Arche from Core, we used to be from Core, Yoshi Kono from the University of Washington, George Washington University, Harvard, those organizations. We had a workshop. And the cost of admission to the workshop was you have to bring a bag of real software security design flaws, real ones. And you have to dump those out in public, and we're going to talk about them. And everybody brought design flaws. We had no idea what we were going to get. We dumped them all out on the floor, and we were like, holy cow, they're the same. And so we piled them up into piles, and we talked about the top 10 biggest piles in Google's code and Twitter's code, real problems. And we, instead of just publishing a list of problems, we published ways to avoid those problems. Now, our advice is very high level, but it's meant for architects. It's meant for people who long ago put down the keyboard and picked up the magic marker. It's such a bummer when that happens. Like, I picked up a magic marker so long ago, I don't even know where my keyboard is anymore. But we've got to make some progress on this design thing. Now, the Twitter people took the document, which you can download for free from there under the Creative Commons. Yes, I made the IEEE put something out under the Creative Commons. Thank you very much. For the first time ever on planet Earth. And they took that thing at Twitter and they pushed it out to their design stuff. They said, well, here's the vague advice from the Center for Secure Design, but here's how we screwed it up, like this in this framework like that, and here's what you should use now, so you don't do that in your future code designer people. Got it? And that's now widespread at Twitter Engineering. That's what you need to do. Who's talking to their architects? You need to be talking to your architects. Good. I saw some hands. I saw some nodding, because we've got to do that. All right, that's the first half of the talk. Actually, that's the first third of the talk. Now I'm going to talk about zombies. Zombies are a little hard for my friend Scott Matsumoto, because he's very literal-minded. And he doesn't understand that the zombies, in my case, are good. Okay? So you got to wrap your head around that. These ideas are supposed to eat your brain and live forever. That's good. Zombies good. Everybody got that? Okay, Scott still, I told him he's just, he tried to give the zombies talk once and he started crying and he had to leave. Right, so the zombies talk. I'll tell you a story. I went to school and did my PhD with Hofstadter, and one of the guys in the group is a guy named Dave Chalmers, who's now a very famous philosopher. And Dave did philosophy of consciousness. Dave and I had huge arguments all the time. Sadly, Dave's probably 10 times smarter than I am, which is really awful. And so, he would always cream me in arguments. But I would always say, well, then according to your argument, I'm a zombie. And I would claim to be a zombie, which drove him crazy. Because I was like, well, I don't have consciousness, and you can't prove that I do. And that drove him crazy, so that's another reason zombies are good. So zombies are really particularly good. Okay, here are the zombies. Network security fails. The more code you have, the more bugs you have. We have to integrate crap into the SDLC. There are bugs and flaws. They are what? What was the number? 70. You people don't listen, right? So, and badnessometers. So I'm going to start talking about these obvious ideas. Why should I tell you guys who practice this every day, with your sleeves rolled up, doing software security, about these obvious ideas? Well, here's why. We've barely begun to scratch the surface of dev, and we're pretty deeply integrated into two verticals. Financial services, I hate that, financial services and ISVs, and that's it. Now, software security is growing very fast. It's probably growing at about 20%, which is twice as fast as computer security. I believe we're about, $7 to $10 billion now and growing at 20%. Computer security is 70 to 80 billion, so we're 1/10 of that, but growing faster. We are the pinky finger of computer security. Woohoo! Some verticals are just beginning to adopt software security. A little too late, like retail. And they're doing it wrong. I mean, they're hiring people from the government. It's like, oh God, you guys. Another 5 years before Clue, right? So seriously, it's ridiculous. If you're here from retail, I'm so sorry. We should talk. And so as we move into these new domains, we have serious issues which we all know and we take for granted that these people don't know. And we have to make sure we tell them these things. It's up to all of us to repeat the obvious to the people that don't know it yet. Believe me, I've been doing it for 20 years, talking about software security for 20 years. And I say the same thing all the time. It drives me crazy. But that's the only way to do it. So we have to do that. I need your help. We all have to do this. So I'm going to tell you the obvious ideas, but I hope that you spread the obvious ideas. Really need your help. Number one, old school security doesn't work. It's way too reactive. The paradigm used to be, I have some broken stuff and I have some bad people. So I'm going to put a thing between the broken stuff and the bad people. What's the thing called? Firewall. Woohoo! Firewalls are great for perimeter security. Perimeter security requires something. Anybody guess what that is? A perimeter! Damn! We don't have one of those anymore. Yeah, anybody heard of like massively distributed computation? You know, anybody heard of the cloud? What perimeter? Right? So if you don't have a perimeter, perimeter security doesn't work because you can put firewalls most everywhere. Oh, on every line? Really? Yeah, so we got to do something else. Penetrate and patch, not so good. We've mostly solved that with automatic updating. Reviewing products when they're done. You know what, guys? If your first interaction with dev is to go, hi, I'm from security, and I broke your shit, and your baby's ugly, and let me just hit you in the face. Bam! And then you want to come back, they're like, security's coming, ah! Everybody runs and hides, and they're like, send the intern! So you talk to the intern because they don't like you because you hit them in the face. When you meet somebody, don't hit them in the face, okay? Right? So if we wait until the end of the life cycle and we run penetration testing and we hit them in the face with the pen testing results and we go, ha ha ha, you suck. They don't like us, right? Instead, we have to say, let's work on this together. We got to teach you how to do this. I know you want to do it right. Here's how to do it right in software language, not web language, right? Too much weight on pen testing. Too much weight on pen testing. Too much weight on pen testing. Okay, got it? Pen testing's good. You should do it. If it's the only thing you're doing, you're an idiot. We're done with that. So it's too expensive. Late in the life cycle, we break stuff every time. You got to fix it after it's already shipped. Dang, the economics are totally wrong about that. Just ask Bruce. He's an economist now, so it's all good, right? Here's how pen testing works in practice. You ready? We hire some pen testers. They're reformed hackers. We know they're reformed because they told us they're reformed. We give them a week and $10,000. No, wait, let me get that straight. We give them a week and $7,000. No, wait, let me get this. We give them a week and $4,000. Oh, did you see that price drop? Still on the way down. If you're a pen tester, controlled flight into terrain. You're going to be paid less. My guys hate when I tell them this. They're like, you shouldn't say that. I'm like, shouldn't, or it's the truth. Which? Right? So, controlled flight into terrain. We need to do it, right? But we pay these pen testers $4K to do a week's worth of stuff, and they find, I don't know, 5 bugs. They tell us about 3 of them. And we go, wow, those are really, I never thought of that. That's great. I'm going to fix those. Let me start fixing those. That one's kind of hard. I'm going to fix this one. I can get that one halfway done. Oh, I can fix this one for sure. So we fix one. We sort of fix another one. And the other one, too hard to fix. And everyone declares victory. Software security's finished. That's not right, guys. You've got to do better than that. We have to do pen testing. Everybody should be doing pen testing. You should have automatic pen testing. You should replace the metal-faced boys with computers. And girls, but mostly boys. With computers. Computers do that boring stuff like monkeys. They like it, right? You don't need monkeys. You need computers. So get computers to do that stuff. And test your whole portfolio because it's super cheap. But don't think that you're done. That's just like the very last thing that you do before you ship. Right? So, and then there's the last thing about old school security. Well, yeah, we do security because we use SSL. Heartbleed. Right? So everything's fine. We sprinkle magic crypto fairy dust everywhere as the last thing. That's not security. That's a feature. Security's not a thing. Security's a property like quality or reliability. And you actually have to build things to be high quality or to be secure. You have to build them to be that way. You can't just bolt on the crypto at the end. I mean, we all know this. I'm not telling you anything you haven't heard a million times. There are many people who have not heard that yet. Here's another biggie. The more code you have, the more bugs you have. Everybody got that? Okay, these 2 chunks we're going to say more code, and these 2 chunks are 3 chunks. You're going to say more bugs. Okay, here we go. I think there was more code than bugs. That's wrong. No, that's right. So, look, no matter how good you get at software security, no matter how much your defect density ratio is dropping, you're producing more code faster than that defect density ratio is probably dropping. This is too hard for some really stupid analysts, who I will not name, who say things like, we should stop doing software security because the bug pile's getting bigger, and so whatever we're doing is not working. And we're like, dude, two variables. Two. See if you can think about two variables. Well, it's not working because the bug pile's growing. Yeah. Two variables. Just two. It's not that hard. Defect density ratio dropping. Code's getting better per lines per square inch, but we're producing more square miles of code than ever. Everybody got that? What we're doing is so working. So those analysts, just tell them to shut up. They're wrong. We have to be the ones who tell them what's actually happening. The stuff that we're doing in static analysis is in fact working. And we are dropping the defect density ratio. That is super fantastic. But we're also producing way more code in our organizations. That's a bummer. So we got to get out in front of that. We got to teach the developers how to do it right. We got to tool them up with the right sort of tools. We got to get better languages, not Ruby. And, you know, that's what we got to do. Now, we used to have this conjecture, more code, more bugs. And, you know, Dan Geer published a famous paper when he was at Stake about that, which got him fired because it was about why Microsoft sucks, because they had a monopoly and their code was bad and it was a national security risk. And, you know, we all knew he was going to get fired before it happened. We were all, like, waiting. So he hit return on the publish thing, and it went on the net. And, like, 5 seconds later, there was a call from Redmond to Cambridge. And they're like, yep, Geer got to go. Okay, Geer's like, I'm already packed. So he was ready. But in his paper, he said, now he's at In-Q-Tel. He's a super fantastic guy. His talks are unbelievable. You need to read his stuff. He's like our philosopher savant of our field. Right, so Dan had this conjecture, and I was like, great conjecture, Dan. Here's the data. See if it's true. And I gave him the Microsoft code pile growth and software vulnerabilities and said, see if it's true. Now, you should never give data to somebody with a PhD in biostatistics and ask them to make stuff correlate, because you know what? He was like, well, that'll take about 2 seconds. Done. And we talk about that in Chapter 1 of Software Security. So if you want to prove to your own organization more code, more bugs, there's data. There's a real little science experiment in Chapter 1 that you can look at. SDLC integration. We all know you have to have multiple touch points in your SDLC. Anybody who believes that their organization has one SDLC works in a shop with more dogs than people, or a startup, or whatever. But as soon as you got like more than 40 guys, there are at least 2 SDLCs and maybe 7. So if your approach to software security is, first, everyone must adopt CMM level 5. You know what happens when you try to do CMM level 5 bullcrap at Twitter? Everybody's like, I quit. Get another programmer. I'm going to do some real stuff. You know, we're doing like agile sprinty, extremely bad programming, fast, right? Woohoo! Guys, I don't want to get into the battle about which SDLC is better. They all suck. Just make sure that whatever you suggest works for them all. Like, check your code, except for the dynamic languages problem. You know, check your code, check your design, train your developer, do some pen testing at the end. There's like, that's just, we know that. Believe it or not, a new idea in 2006 when I wrote software security. It's not a new idea anymore. And then after that, like 2007, 2008, 2009, there were methodologies popping up like mushrooms all over the place. I mean, for God's sakes, even PricewaterhouseCoopers had one. That's a joke. Even they had one, right? So everybody looked like mine. Everybody had one, right? And there was like, mine's better. No, mine's better. And at Fortify, the technical advisory board, they asked Pub to come up with a new one. And Pub came and started presenting Pravir Chandra. He was like, here's the way you should do software security. And, you know, he was getting eviscerated by Fred Schneider from Cornell. He was just like, ha, 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 I have my razor. All your skin belonged to me. Right? So, you know, I saw this happen. I'm like, whoa, stop. Don't kill him. He's good, right? Don't kill him. So I based on one data point. How many lines can you draw? Anybody know? Infinitely many. Yeah, so if your theory is based on one dot, you're a pretty bad scientist. So a lot of arguing over, well, my way's better, my way's better. Well, I'm the Pope. Well, I'm the anti-Pope. You know, I have a Pope hat. My Pope hat's taller. That's the way it was. There's still a little bit of that going on. And we decided, you know what, enough of this Pope crap. Enough of this methodology for software security. Why don't we go out and get data from companies that have been doing this for a decade? We'll see what they're actually doing. That, my friends, is where the BSIM came from. So it was trying to get past methodology of the minute and towards something about what's really going on. Bugs and flaws. What's the number? 70/70. That's good. Getting better, getting better. Badnessometers. Real quick on this one. All right. You cannot test something into security. If you have a set of canned tests, let's say we take, I don't know, who's the latest fad? Moxie Marlinspike. We put Moxie in a jar. Right? So we have Moxie's brain, at least some parts of it, in a jar, and it's totally automated. And we run that automated thing against any arbitrary program. Now we run the Moxie jar against program A, and it breaks program A. It's a jar of tests that doesn't know anything about program A. And it breaks program A. The jar of tests just broke program A without knowing anything about it. What do we know about program A? It's broken. Somebody said it here. There's a technical term. It sucks. Yes. Can of tests broke your code. That code sucks. The can doesn't know anything about your code. Now, imagine that we run the same can of Moxie tests up against program B, and they don't find any problems. What do we know about program B? Nothing. Oh, no, we know one can. No small cans worth, right? But what it's not is a security meter. Not a security meter. Your VP of idiocy and security, over above you, 3 layers, that guy would like to have a security meter. Everybody would like to have a security meter. There are some vendors that pretend if you put software in a little box and the box turns green, everything's secure. Any computer science people in here? You know, you ever heard of the halting problem? We can't even tell if the damn thing's going to stop, much less if it's secure. Did you hear that? We can't tell if it's going to stop, much less if it's secure. So if you want the magic box and the vendor's selling you the magic box, either they are hucksters and liars or they are really bad computer scientists. Take your pick. Or both. It could be both. That's a good point. I never thought of that. Damn, I've given this talk 50 times and nobody said that before. So that's really good. So anyway, what we end up with is a badnessometer, right? We run the canned test, it breaks our program, and it goes all the way to beep, 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 deep trouble, boop, boop, your code sucks. Don't ship it. You know, and it's an automated test, so it's super cheap and it's good when it goes beep, 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 don't ship it. Real idiocy involved, right? And then we run it again against another program. It goes all the way to ding, 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 ding. Does ding, ding, ding mean secure? No, it means, yeah, I don't know. Never forget that that's all it means. When the VP of yada yada and idiocy says, well, we're just going to use the black box scanner doohickey static analysis binary thingy just to approve or not code, you have to say, all right, let's talk about computer science theory for just a minute. Let's talk about reality for just a minute, right? So don't forget what you learned about testing when you were doing QA stuff back a million, trillion years ago. All that is right. It's all right. I have an extra bonus zombie. Check this out. Yeah. I was giving this talk in Buenos Aires. It's kind of a small crowd, about 200 people. And there was this hugely pregnant woman in the front row. And I put up that slide, and she kind of went, ah! And I was like, I'm so sorry. I didn't anticipate there. I'm sorry. The zombie baby we already talked about. If you don't fix the stuff you find, you're not helping. All you're doing is identifying a problem. And if your division is only in the business of problem identification, everyone is going to want to eradicate your division. Right? Because you're a pain in the ass. So don't be a pain in the ass. Make sure that you help people fix the things that you find. And if you find a problem, don't gleefully present it. I know it's hard not to do that. When we break things at Digital, which we do all the time, and do we put it in the newspaper? No, because those days are over. That was the 90s, right? Now people listen. We call them up on the phone, and you just say, it's broken this way, and here's how you fix it. Here's how you need to fix it. Always offer the fix. If you don't know the fix, find somebody who does. Don't just run around throwing rocks. Throwing rocks is really, really easy, and we have to be done with that. Right, touch points. Everybody has a software security group. We did this in 2006. There's the touch points. Yay! What are the top 3 touch points? Well, if you have software artifacts, which are boxes in any SDLC, what's the one artifact that every software project has for sure? Code. Right. There's some government projects that don't have that yet, but they're going to have it soon, pretty soon, right? So short of that, you got to have code. You got code, and so you go up from the code box and you go, oh, code review tools. I see. That's what I'm going to do. What's the second most important touch point? Hint, bugs, flaws, 70/70. What's the second most important touch point? Architecture and design. Architecture risk analysis, exactly right. Microsoft calls it threat modeling. Why? Because they use nomenclature from New Zealand, right? We use normal nomenclature from the United States war pile in the United States. But if you're Mike Howard, you're from New Zealand, and so you call it threat modeling, and threat means risk in New Zealand, and the war people talk differently than we do here. And you know what? We're stuck with that term because Microsoft has a big old marketing budget. Although yesterday they laid off a bunch of people out of the central security group. I don't know if you saw that or not. There were big layoffs in Microsoft yesterday. Now I'm going to spend 3 minutes and 4 seconds talking about the BSIM. That's what happens when you take a 90-minute talk and mash it down. I already told you where the idea came from. The idea was we're going to go gather data, and we're going to take the data, and then we're going to look at the data, and then we're going to build a model to describe the data. I just said data, 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 right? Real data, take it all, build model. Now, this is weird because computer science, the way we usually do it is, well, I have a pet theory, so I'm going to build a big old system, and then I'm going to try to justify it with a little bit of data. But in most sciences, it works the other way around. I got a big old pile of data, now I'm going to try to model that data. That's what the BSIM was about. We are now up to 87 companies. We're shooting for 100 for BSIM 6. And the last version that we published for free under the Creative Commons at bsim.com includes data from 67 firms. Here they are. Pretty much every single major bank on planet Earth, because there are 22 anonymous firms up there. Damn, I really got to figure out why that's happening. Oh yeah, what do we got here? So here's a big old bank. Where's JP Morgan Chase, that's a big old bank. Oh yeah, they're not supposed to be on that slide. There's some people that are trying real hard. Yeah, they're trying real hard and stuff. There's like, what do we got? Oh yeah, these are the guys who do like 20 trillion, just unbelievable amounts of wire transfers everywhere all the time. There's the people that do all the clearing for for Wall Street behind the scenes. There's like security vendors, check that out. F-Secure, and Symantec's up there somewhere. This is a lot of software. Let me tell you how much software this is. This is real data from this many firms. And there's one number on there that I want you to see. We are, in the BSIM, in our community, with the software security professionals that work full-time on software security, of which there are 1,000 people, with 2,000 other people that really do full-time software security, but they're distributed throughout the rest of the organizations. So 3,000 people, 976 plus 1954, trying to control the work of 272,358 developers. My friends, this is real. This is not pretend, little boy rock-throwing nonsense. This is how we do software security. Now, these people might all be doing it wrong, but they're doing it wrong the same way, which is very, very interesting. Now, here's the real question. We got 250,000 developers up there. How many developers are there on planet Earth? I think about 8 million. And, I try to slice the number, dice it a million different ways. 8 million's probably the right order of magnitude at least, right? So 8 million plus or minus 2 million. That sound good? We are 1/29th of the way done with the BSIM. 1/29th of the way done. But we're describing the work of 250,000 people that are building software that you use today. You cannot avoid having the BSIM have touched the stuff that you work, even if you do all open source all the time. Of course, you can't do that, right? So let me tell you how we built this thing. We built it by going out into those 67 jungles, and we said, oh, look, in jungle 1, monkeys eat bananas. In jungle 2, no monkeys. In jungle 3, monkeys eat bananas. In jungle 4, monkeys eat bananas. Wow! In 32 out of 67 jungles, monkeys eat bananas. That's how it is. It's just a descriptive model. Is eating bananas good? I don't know. They do it. The BSIM is just, that's what they do it. Seriously, it's a descriptive model. It's not wrong, it's just a fact. Only Republicans can argue against those, right? So global warming. So, sorry, excuse me. So, it is not a prescriptive model. What it does not say is you should do it this way. It doesn't say things like don't run while you eat bananas, or only eat yellow bananas, or thou shalt not steal thy neighbor's bananas. It says none of those things. All it says is how many jungles monkeys are eating bananas in. And when we divide that stuff into these practices, we end up with a bunch of activities, which I don't have time to tell you about because I'm 2 minutes over. You can read these slides later because I will give them to you guys and you will post them somewhere. Plus, this is being live streamed, so it'll be on YouTube. Yes, very soon. I do want to tell you a couple other things, though. When you look at real data, you begin to find things out like how big SSGs really are and how big development teams really are. And if we divide those numbers out, we find out that 1.4 is the number of full-time software security people in these 67 firms trying to control their developers. That's just the real number. Is that the right number? I don't know. That's just the number. Now, so you should ask yourself, does my firm have more or less people doing software security than that number? And do I care? I mean, if you look at the BSIM members and you're like, wow, they all totally suck and I don't want to do it like them, then the BSIM. But if you look at that and you go, wow, I have a bunch of peers that are doing software security full time with millions of dollars of budget and hundreds of people, 1,000 people, and here's how they do it, and I can count how many times they do various activities, and I can chart myself against that, so I have me versus the rest of the world, and I can even do it in high resolution, then we're beginning to get something that we desperately need in security, which is called measurement. We can't do science unless we can measure. Lord Kelvin was absolutely right about that. You cannot improve if you can't measure, because you don't know where you are. So, are you measuring your software security initiative? What yardstick are you using? I don't care if it's the right yardstick, by the way. Remember when we came up with the idea of a thermometer? There was just some crazy coot dude who drew lines on a column of mercury. And I'm sure there were people that were like, dude, I don't like your lines. I like my lines better. My lines are slightly different. Whatever. Just use it the same way every time, and pretty soon everybody will be using it. We'll call it Fahrenheit scale, because 212 is a great number. And so is 32. I love the English system, by the way. I love it, because the English system reminds us that we're human beings. It's like, yeah, there's 5,280 of those in one of those. What? What? Yeah, there's 12 of these in one of those. What? I love it. It just makes me so happy because it's so human, right? So we're coming up with the English system of measurement for software security. You heard it here first. Mess and all. You guys, you can do the metric system if you want. That's totally cool as long as we all use measuring sticks. We're all going to say from now on, we're going to measure what we do in some way. We're going to talk about it the same way. And we're going to try to make progress because we can measure it. If you want to get involved in the BSIM with your firm, just get in touch with me. It isn't free. It used to be free to get measured. And then I went into my boss's office one day for a meeting, and he was like, this was about BSIM 2 time, right around 30 firms. He goes, hey, this is cool. Your project is awesome. It's great, and everybody loves it. You know how much you've spent? I said, nope. He said, well, I do. About $250,000. I was like, oh, yeah. It's like, how big are you going to make this project? I said, I don't know. It's escaped the test tube. It's growing really fast. Really big? It's like, find a way to pay for it. And so now we charge people some modicum to get measured because we're just trying to run a science experiment that's totally out of control and growing like a weed. Right? So sorry about the not free part, fellas, but I'm a capitalist. Right? So where to learn more? Last 10 seconds. I write a monthly column for Search Security. This month's column is about the Center for Secure Design. So if you don't have a chance to catch up with Dell or get a copy of the report from the Digital booth, which there's still some left, Dell? There's still some left. It's really good reading, honest to God. Then you can read that article, and it has pointer to the thing. I've done that for, 5 years in a row. So there's a whole bunch of articles there, all up. We have a blog. Our blog's cool. I have this podcast called Silver Bullet. We just did the 102nd monthly interview in a row, 102 months in a row. There are over 1 million downloads of this thing. And it's kind of cool because I spend a lot of time, you guys, doing the script with the questions of the people that are my guests, and I don't tell them what they are in advance. Right? So I'm trying to extract lots of knowledge from really good people's brains. There's some fantastic episodes. My favorite of all time is Ross Anderson's first episode. The current episode that went out yesterday on the RSS feed is Richard Danzig, who used to be the Secretary of the Navy. And Richard just recently decided to get into computer security so he could write a paper to get policymakers to understand what the hell it is that we're doing. And he spent a long time working on that. He is super elite, amazing intellectual guy, but he speaks Washington policy, which to me is like, I don't know, it's like Turkmenistanistan or whatever. Some crazy language that's incomprehensible. And I believe that he may actually be making some progress in the government. So cross your fingers. By the way, the BSIM, 0 government contractors, 0 government agencies. The government is 5 years behind in software security. Sure, they're good at offense. They're terrible at building security in. And we have got to fix that, you guys. Now, there are little pockets of goodness. The Swamp Thing is a little tiny pocket of goodness. So can't paint everybody with that wide brush. There's lots of great people in the government. But our own government in the United States, 5 years behind. That's not good. I'm not happy about that. There's this book, Software Security. I'm doing a book signing. I think it's really at 10 and not at 9. I don't know. Maybe it's now. I'll go over there eventually. So if you don't have a copy, I think there's some over there. So get over there quick if you don't have one. If you do have one, would you just read the damn thing? I mean, really. Get it on BitTorrent. I don't care. Just read the damn thing, okay? So shelfware, not helping me any. Right? If everybody in this room bought one of those copies of the books, I'd make like $6. So get on it. Right? I care about software security. I care about doing the right thing in software security. And I care about what you're doing, all of you, in software security. If you want to ask me a question about our field or you want to interact about this stuff, I am always on the net. You'll get some sort of big lie bounce thing. McGraw is dead and lives on Mars, but it's not true. I'm actually on the net. And I do care about this field. I would love to help you work on this stuff. It's important what we're doing. This is the way to do computer security, and you're doing it. And that's super, super important. Because we got a long way to go. Even the BSIM is only 1/29th of the way there. We have a lot of developers to touch. We have a lot of software to fix. And we have big, big issues to grapple with. And we have to do it together. So thanks for your time today. That's all.